Well, now I've built a compound setup at the engine, not in the engine bay, so you can see it a little bit better. I'll explain what I'm doing. First of all, distribution here. Normally this shaft here goes to the oil pump, which is really shitty on these engines. So we have a shorter belt from a 1600 TD, and with this custom pulley, well, it's not going to fit right now, but it does fit. With this custom pulley I got 23% higher shaft speed. The shaft is modified at two places because this actual bearing that sits right here always breaks off because it's cast iron. Now it's not cast iron anymore, and there's really a lot of I think you call it unbalanced. It's not balanced right. The shafts are not straight, so someone is making them a little bit thinner, which actually really works really well, and it's a big company that does that. So that's for the oil pump. Well, here we got the intake manifold. It's not finished yet, but it's got a lot shorter runners and a much bigger chamber than my Mark 1 layman manifold, which you can see right here, which had long runners and only had 1300 cc's of volume in the first chamber, which is wrong. It's supposed to be at least as big or bigger as engine capacity. So somewhere this will fit in. It's going to be welded on to here somewhere. It's nice and smooth, so you don't got as much turbulence. And then you need a cone to fit right on there with a hose from the second charge cooler. So far for the intake. I would like to have round caps on here, but with compound there's not much room here. You see a lot of exhaust pipes. That's all going to be heat wrapped. For the explanation, here we got your normal exhaust manifold. Well, this one is custom. It's big. It's bigger. It's better flowing. We got EGT sensor, we got exhaust manifold pressure, we need that, so we can see what the small turbo is really doing. We got a custom RPM shaft sensor, well, impeller sensor really. It's from a V10 TDI, and it's CNC made to fit this KO3. It's a billet wheel. There's going to be a lot of forces on these on this small turbo. I don't know how long it's going to last, but we'll see. At least it's not going to be spinning so fast. Only 40% of the exhaust volume at full boost will go through the turbine. The original wastegate, which is still here, is not going to be used because this is the new wastegate, this 60mm gigantic motherfucker, which could cause a little problems, but I'm not going to talk about that right now. 60% of the total exhaust volume will flow through here and merge together with the other 40% downpipe together, go into the turbine of a low pressure turbo. Low pressure turbo is a 71mm compressor. This is only going to do 1 bar of boost. It's got its own wastegate, small wastegate, which is absolutely enough. I'm not going to run screamer pipes because that will only get you in trouble with the law, so it's coming in the downpipe. And I already got the 3-inch stainless steel down exhaust on the car, so that fits. No, this is not the cylinder head or pump I'm using, just like this engine, it's just a model. Well, because this is variable, but it's very hard to time the camshafts correctly. So got this plate laser cut, and we're gonna cut the pulley in half, so it's gonna be adjustable. 4 degrees is what it gives me, so I can time my 260-degree sport camshaft better. For this piece of art, it's a check valve jet, atomizing jet, because it's aluminium on aluminium for the high pressure turbo. This is where the actual heat is being produced. The air is being compressed for the second time. I'm going to build this in. This is going to be a pre-turbo injection. It's got pros and cons. I'm not going to work with methanol anymore because I think the boost and the compression is going to be so high. I'm afraid that it will detonate by itself before the piston is at top dead center. It's only going to be water injection. It's going to be a little water injection, about 100 cc's at 300 psi. At 300 plus brake horsepower, that's not much. And the only reason I'm injecting here is I hope this will cool the compressor, and it prevents it from expanding too much and hitting this house. Some manufacturers like Cummins use iron compressor housing, which is not an option for me, or titanium reel, which is not an option for this turbo. So I'm going to do it with a little water injection. I hope the water injection is not too much so that it will raise compression, because the compression is going to be very high in this engine, and the cylinder head gasket's going to have a real tough job keeping it together. Another thought of mine, we're not sure we're going to do it. This is this peak cylinder pressure. It's not only glow spark, but it can also give you an idea of the maximum peak cylinder pressure. It's going in the same location as a normal glow plug. If we use this, then we need another trigger wheel, which has exactly 13 degrees after top dead center, gives a pulse, and when that ends up simultaneously, what a word, with the signal from this sensor, that means that you actually have the bang at the right moment. So that's one thing I'm thinking of producing. Of course, this is I'm working on a ported head. Then you think, yeah, how you know where to remove the material? Well, we had a head here which was ported CNC by a good company for a lot of money. Here you see original versus the ported head, and I got lots of pictures of it, and not only the pictures. In here are the sizes and little wires bent in the right position. If it fits, it will fit. So so far from modifying the head, I think I'm going to use H-beams as well. And I need a lot of parts from the engine here on this picture, which is fuel pump, camshaft, grindle. Maybe you can see it here. You see a second layer between the block and the carter. There's a layer which actually holds the whole thing together. And yeah, this is going to be my turbo compound engine. I don't know when I will finish it. There's time, money, everything, but I will.